Welcome to The Explainer, where we break down complex topics into clear, understandable presentations.
All right, so today we're jumping into part 9 of this really detailed report from RFI Detectives. They cover all things Wi-Fi and Bluetooth standards. In this chapter, it's all about the standard that completely changed the game, the one that brought gigabit speeds into our homes and offices. Yep, we're talking about Wi-Fi 5.
Okay, so let's set the stage a bit. To really get why Wi-Fi 5 was such a big deal, we first have to understand why we were so desperate for a new standard in the first place. So, cast your mind back to the early 2010s. Wi-Fi 4, 802.11n was the top dog. 600 megabits per second felt crazy fast, right? But then, everything changed. We started streaming HD movies, using cloud apps for everything, and suddenly, everyone had a phone, a tablet, a laptop. The number of devices just exploded. Our networks started to groan under the pressure. We were hitting a wall, a serious bottleneck. The demand for speed was just completely outpacing what our Wi-Fi could deliver.
So yeah, this huge demand for more and more bandwidth really set the stage for the next big thing in wireless tech.
And that answer came in 2013 with Wi-Fi 5. And look, this wasn't just a tiny step up. It was a massive engineering push with one main goal: to absolutely shatter that gigabit per second barrier for wireless. It was all about completely changing what we thought was possible for Wi-Fi speeds.
So the big question is, how did they do it? How did they pull off this huge jump in performance? Well, it really comes down to three key technologies, three main pillars. Let's break them down.
First up, they basically made the data highway way wider. We're talking about introducing these massive 160 megahertz channels. Think of it as adding a ton more lanes for all that data to travel on.
Second, they figured out how to pack more data into every single signal that went out. They used a much denser modulation scheme. You'll see it called 256 QAM, which just crammed more information into every transmission.
And third, and this is a big one, it got a whole lot smarter with something called multi-user MIMO. For the very first time, a Wi-Fi access point could actually talk to 4 different devices at the exact same time. This was a complete game changer for network efficiency.
So you put all that together and what do you get? A theoretical speed of 3.5 gigabits per second. I mean, that's nearly 6 times faster than what we had before. Just a massive leap forward.
Okay, let's dig into that first pillar a little more: channel width. The highway analogy is honestly the best way to think about this. If you have a 2-lane road, you can only get so many cars through. But if you double it to 4 lanes or even 8, suddenly you've got way more capacity and less traffic. Wi-Fi channels work exactly like that, but for your data.
And here's the really crucial word on this slide: mandatory. See, Wi-Fi 5 didn't just make 80 megahertz channels an option, it made them the new standard, the baseline. So right out of the gate, the data pipeline was doubled. And then it gave you the option to double it again to 160 megahertz. Just an incredible boost in potential speed right from the start.
All right, next up, let's talk about modulation. How do you make every trip on that highway more efficient? Well, if channel width is making the highway wider, modulation is like figuring out how to fit more people into every single car. More data per trip.
So here's the key takeaway. We jumped from what was called 64 QAM to 256 QAM. Now, what that really means is that every little piece of the signal, every symbol, could now carry 8 bits of data instead of just 6. Think about that. That's a 33% speed boost right there without using any more of the airwaves. But, and this is a big but, there was a catch. Packing data that tightly makes the signal way more fragile, much more sensitive to any kind of interference or noise.
And that brings us to the third pillar, how Wi-Fi 5 got so much smarter about handling traffic. Now, older standards could already send multiple data streams to one device, which was cool, but they could still only talk to one device at a time. It was like a one-on-one conversation. Wi-Fi 5 brought in something truly revolutionary for busy networks: multi-user MIMO.
And this slide really shows you what a big shift this was. Instead of the access point having to quickly talk to one device, then the next, in this sort of round-robin style, it could now use its antennas to have a conversation with up to 4 devices at the same time. I mean, if you're an IT pro trying to manage a busy office or a classroom full of laptops, you get it. This was a huge deal for making the whole network run better.
Okay, so we've talked about all the cool theory, but now let's get real. Let's bridge that gap and talk about what happens when IT pros actually have to deploy this stuff in the real world. Because as you probably know, getting those top-of-the-line speeds isn't always as simple as just plugging it in.
Okay, remember that catch I mentioned with 256 QAM? Well, here it is in black and white. To get that awesome 33% speed boost, you need a practically perfect signal. We're talking a signal-to-noise ratio of around 30 decibels or even better. What does that mean in the real world? It means it only really works when your device is pretty close to the access point and there's not a lot of other noise or interference gumming up the works.
And that's just one piece to the puzzle. When you're rolling out Wi-Fi 5, you quickly realize other things, like finding a clean, empty 160 MHz channel in the 5 GHz band. Good luck, it's crowded in there. Plus, even if you find that perfect channel, the devices at the edge of your coverage area, they're smart. They're going to automatically drop down to slower, more stable speeds anyway. So getting the most out of it, it takes some serious planning.
So when you take all this into account, the good and the complicated, what's the lasting impact of Wi-Fi 5? What's its legacy?
I mean, just look at this chart. Whether you're talking about channel width, how much data is packed into each signal, or how it handles multiple users, it's a clean sweep. Wi-Fi 5 wasn't just a little bit better. It was a completely fundamental upgrade, a true generational leap. It basically set a whole new bar for what we expect from our wireless networks. And really, that's the biggest legacy of Wi-Fi 5. It took gigabit-level wireless and made it normal. It made it the expectation. Wi-Fi went from being this nice-to-have convenience to a legitimate replacement for a wired connection in a ton of situations. But in solving the problem of raw speed, it shined a huge spotlight on the next big challenge for wireless.
And that leads to a really interesting question, right? Wi-Fi 5 gave us all this raw speed. But in a world that's just jam-packed with devices, is speed the only thing that really matters? This is the exact question the creators of Wi-Fi 6 obsessed over. How do you build a network that isn't just fast, but is also super efficient, especially when you've got dozens, maybe even hundreds, of devices all trying to talk at once? But that's a story for our next explainer.